All right, so I think this is recording. Let's take a look here at this product. They want us to simplify this. When we see that we have negative radicands, we know if we're working within the set of complex numbers that introduces I into our answer, because we know that the square root of -1 is defined to be this imaginary unit I. So um, the square root of -49, well, that negative sign introduces the imaginary unit, and we know that 49 is a perfect square, that the square root of 49 is 7. And over here we've got 3 times the square root of -4. We know that negative sign is going to introduce I into our answer, that 4 is a perfect square, that the square root of -4 is 2I, and that's going to get multiplied by 3. And then over here, we know that the square root of -9, that negative is going to introduce I into our answer, the imaginary unit, and the square root of 9 is 3 because 9 is a perfect square. So we have 6 minus 7I times 6 i's plus 3 more i's. Now, I remember that some students went ahead and jumped in and did the table here, but when you have 6 i's plus 3 i's, you can combine those and look at this as 6 minus 7I and times 9I. And now all I have to do is the distributive property. I don't have to create a table because I'm just, or if you do, your table is just a 1 by 2. I suppose if you insisted on making a table, write 9I, and then you've got 6 minus 7I. You know, if you want your table to be like our tic-tac-toe board, put a 0 here because you've really got 0 plus 9I, and I squared is -1. That changes the sign of the -63 to a positive 63, and that's all we have is 63 plus 54I. Now, I went ahead and wrote the 54I as the second term to write it in standard form. Remember, standard form for a complex number is A plus BI. So the 9I times the -7I got me the -63I squared, but that's 63. So I went ahead and wrote that part first, and then the 6 times 9I was the 54I. So this is our final answer. So I hope that helps, and I will talk to you later. Bye.